Okay, let's start with our DSA with C Sharp series. But first thing, why DSA with C Sharp? Like normally people do DSA with Java or C++. So consider you are a .NET developer and you are going for interview for .NET with C Sharp. What will you say? Okay, you can ask me any question on .NET C Sharp, but whatever DSA question you are having, I'll solve those using C++. Don't you think that's a little weird combination? And for my own preparation, I check lot of playlists on YouTube, but trust me, I didn't find single playlist that has explained end to end all topics along with problems. So I went on Udemy, I purchased few courses, and whatever I have learned, I'm sharing that into this community. So if you want paid material for free, consider hitting subscribe button. So let's start. By the way, I am a software developer having 3 years of experience with .NET. So now we can start. In our DSL C# playlist, we are going through all the topics. Here you can see how we are gonna go. So first we will go through recursion, then searching, sorting, linked list, and all DSA topics. And after that, we will go into problems. So when we are solving problems, our this concept will also get revised. First, we will understand what is recursion. Then we will see there are four types. So on high level, we have four recursion types: head recursion, tail recursion, tree recursion, and indirect recursion. You can see that over here. And after that, we will see what is recurrence relation and how to solve that so that we can get time complexity for recursion. Okay, so what is recursion? Basically, a program that is calling itself to do particular task, we call that as a recursion. And that function responsible for doing this, that function is called recursion function. And on higher level, we have three conditions in recursion. One is condition so that we can break the recursion loop. Second, our core logic, and third, recursion call itself. We'll see all those three in our these four types. So while implementing these types, we will see those three conditions. Let's go into code so that we will understand better. So here I am writing code for head recursion and I am taking example to get some of n numbers. So let's start. First, we are having our condition to break the recursion loop. And what that will be? Here I am taking n is greater than 0. If n is greater than 0, then only I am doing recursion call, otherwise I am exiting this recursion loop. And here I want sum, so I'll take one variable to store my sum. So what sum I want? N, and sum of n minus 1. So recursion call n minus 1. Why n minus 1? Because n value I am already having here. Whoever called this function, he has passed n. Consider n is 4. So 4 I am already having here. I want values till 3 only. So whatever value from 0 to 3, whatever sum from 0 to 3, that I want, and that I'll get through this function. That's why I'm passing here n minus 1. And I'll print those sum as this flow will go. So that's why I'm writing this console line, and I'll return our sum. I know we can return our sum from here as well, but I want to show you one thing. So that's why I'm writing like this. Okay, and if this if condition is getting false, I'll return 0. Why 0? Because this will false when my n is 0. So that's why I'm returning 0 over here. Let's call this function. I'll explain this flow also, don't worry about that. I just want to show you output, how we are getting output. So that's why. Head recursion. Okay, IntelliSense is helping me here, and let's execute this program. So see the output here, we got our final value 10, but if you see flow is in particular order, that is in ascending order. So let's understand whatever output we have got, why we got in that order only. I'll draw one diagram. If you see, our first n value was 4, and what I did first is I called the recursion function. I didn't call console dot write line. If you see after if condition, because this is head recursion, first I called recursion function directly, so this line is not executed yet. We again went back into our recursion mode, and here I'll store value of n also, like sum also. Let's copy this guy. I call this function with value of n as 3 because I am doing n minus 1. So here it is 3, here it was 4. When I call this guy again, I pass value of n as a 2 because n minus 1. And remember, till now console.write line is not executed yet. This time value of n is 1. N is still greater than 0, so our if condition is not failed yet. We are still gonna do one more recursive call. See over here, our if condition is n is greater than 0 and 1 is greater than 0, so we are gonna do recursion call once more. This time our n is 0, and because n is 0, see here, we will not go inside this if block, we will directly return 0. So what we did here, because our if block failed, we return directly 0, and this 0 we got over here, value of this recursion call, that is 0. Now what is 0 plus 1? 1 only. Over here I got 0. Now 0 plus 1, that is 1, so value of sum 1. After this line got executed and value of sum was 1, so here first output we got was 1, and after printing that line we are returning 1. Here value of this recursion call, that will be 1. Now what is 2 plus 1? It's a 3. For this recursion we got 1, and at that time value of n, that was 2, so sum was 3 and we got second output, that is 3. Same over here, for this recursion call we got 3, and 3 plus 3, that is 6, output is 6. And here you can see we are returning sum, and sum was 6, so here we will get 6. 6 plus 4, it's a 10. We got out last output, that is value till n, and n was 4, it is 10, and we got our answer. The only thing that I wanted you to know, because this is head recursion, all the output that we got is in ascending order. Okay, now let's understand what is tail recursion. So I'll write one more class for tail recursion, and I'll take one function. So for understanding purpose, we will take same example, but instead of doing sum, we will just print the values. What is value of n, so that we will understand little better. I'll write the same condition. So first we will write our exit condition, that is n is greater than 0. First I am printing value of n. Why? Because in tail recursion, recursion function call should be the last. So that's why whatever logic I am having, first I'll execute that logic and then I'll do recursion call. Why n minus 1? Because n I am already printing here, and in second iteration I want n minus 1. And if value of n becomes 0, then this if block will become false and our recursion loop will get break. Let's run this guy also and we'll understand how this is behaving. So I'll comment this part, and my good intelligence is helping me here. Tail recursion dot, and let's execute. Okay, we got the output. And if you see, for tail recursion we got output in descending order. For head it was ascending order, whereas for tail recursion it is in descending order. Why so? Let's see the code. In head recursion, whatever value I am having for n, instead of printing that first, I am doing recursion call. And in recursion call, my value is getting subtracted. So if it's 4, then in recursion it is becoming 3. In that recursion, 2. In next recursion, 1. And after, when I got returned from the function, first I print 1 over here. as you have saw this in our diagram also over here. When I got written from here, I got that value, I did the sum, and then I print that value over here. Here I did console. Like this I did for all the functions. So that's why we got value over there in ascending order. But here if you see, whatever value of n I'm having, first I'm printing that value. So I was having 4, first I print the 4, then I did the recursion call. When I did recursion call, my next value become 3. So first I print the 3, then I went into recursion call. Same flow till n becomes 0. Once n becomes 0, my loop got exited, this recursion loop, and I got this output. If you are still not clear and you are having any question, please do comment and I'll take those in next video. Okay, let's understand third type, tree recursion. So tree recursion is nothing but a function in which we are doing recursion call more than once. So it should be at least twice or more than two. So for this we will take example of Fibonacci sequence, and this could be interview question as well. So focus on this example. Fibonacci sequence is like this over here. So it start with 0 and then 1, and next number is sum of previous two number. So sum of this is 1 only, then sum of this is 2, then sum of 2 and 1 3, sum of 3 and 2 5, and it goes like this. So for our example, we will find out Fibonacci sequence number of nth position. So if n is suppose 5, then our answer should be 1, 2, 3, 4, 5. Our answer should be 3. If n is 6, our answer should be 5. Like this. So let's start for its code. First we will write exit condition that will help to break recursion loop. And for this example, we will have two exit conditions. There is no condition like we should only have 1, 2, 3. We should have at least one exit condition. So first write exit condition. If n is equal to 0, I'll return 0. If n is equal to 1, I'll return 1. Why I wrote these two conditions? See here. At first position, our value is 0 only. So my mistake. Here it should be 1. For 1 it is 0 and here it should be 2. Sorry for misunderstanding guys. So at first position value is 0 and at second position value is 1. So that's why when n is equal to 2, I am returning 1. Okay. And now our recursion call. I am returning a recursion call itself but with value of n minus 1 plus value of n minus 2. What Fibonacci sequence says? He needs sum of previous two numbers. So if I am looking for value of 2, this 2, I need sum of n minus 1, that is this one, and I need sum of n minus 2, that is this one. And that's it. This is the example. But for better understanding, I'll take this output into one variable and I'll print that also, as well as I'll print n also. So console dot okay, this will help for better clarity. Tree recursion, I'll give 6. I want value of sixth number. So my sum should be 1, 2, 3, 4, 5, 6. It should be 5. Let's see what we will get. Okay, you can see my final sum is 5. That means we got our correct output. But why I got output like this? If you see the previous flow, why it is like this? See, n equal to 2, I got multiple times. Here also, Here also, why it is like this? So we'll take little shorter example and then we will draw diagram for that. Okay, why shorter example? So that diagram will be easy and you will understand in better way. See the output here, our final sum is 2 and for fourth number if you see 1 2 3 4, answer should be 2 only, so we are correct. Now let's analyze the output. I'll take this output with me. So this was our output. First see the code. What we are doing here. Value of n, that is 4. I print that value 4. That means I got this output, this first one. After that I call this recursion function, this guy. Let's draw diagram parallelly. This recursion function I call. Here my value of n is nothing but 4. Okay, when I call this function again, my value was 3. When I came with 3, first I here on this line, first I did console.writeLine for 3 and you can see output is 3. After that I came here, I did call for n minus 1 only. Here also I will make it little cross. Here my value of n is 2. When I come with 2, first I print n, that is 2 over here. You can see in our output, first I print the 2. After that I check this exit condition, that this is false, but this exit condition become true and I return value 1. When I return the value 1, over here I got output as 1. Let me draw diagram also. Okay, so over here I got output as 1 and I got return where over here. Here my value of n is 3. When I came out from this guy, I called this recursion function and at that time my value of n, it was 3. So 3 minus 2, 1. So I did next recursion call with n as 1. You can see here value of n, it was 3 and I did call with n is equal to 1. Why? Because this call was belong to n minus 2. This was the second call. When I did n minus 2, my n value was 1. I came here again. First I print my n, that is 1. So after that you can see n is 1. And because my exit condition is also true, I return 0 from here. So you can see here I return 0. Now because this two output got returned over here for n minus 1 and n minus 2, my sum become 1. Why? This guy returned me 1, this guy returned me 0. Sum become 1 and then I print sum, that is 1. You can see over here. After that I got return from here also, from here to here, and when I came out from this function for n3, see over here, for n3 when I came out from this function, now my n value of n is 4. So I called this function for value of n 4 and here I am doing minus 2, that means next subsequent call will have value of n, that is 2. So over here you can see value of n, that is 2. So again I came into this function, my this if block got true and I return my flow with value 1. So this guy got returned over here with value 1. This second function, as this came back with value 1, one from this block and one from this block got returned over here, and here we did sum. What is sum? 1 plus 1, it's a 2. So we got sum as a 2, and you can see here sum that is 2. Why we got this n equal to 2? We got that output over here. Here we were having n that is 2. So we first print that value over here, and then we return 1 from this condition. Now if you see this diagram is looking like tree, and that's why we call this type of recursion as a tree recursion. Understand? If you understand only this one example, it may help you in interview to explain recursion as well as solving this example. And now final thing, that is indirect recursion. There is nothing much in indirect recursion. I'll explain you quickly. So let me write class for that. I'll take two function here, func A, public void func B. Indirect recursion says from function A I am calling function B, and from function B I am calling function A, then this is indirect recursion. Okay, I did typo here. It's very simple. You can see I am not calling function A from my function A itself. I am calling B and B is calling A, and it is like this infinite symbol kind of thing. And now let's understand how to find out time complexity using recurrence relation. So first, how to get recurrence relation. If you see here, as a time complexity perspective, this line will take constant time. It's a simple if condition. Here, this line also will take constant time. Same will be over here, and same will be here as well. All these lines will take constant time. This line will take t of n minus 1 time. Why t of n minus 1 time? This entire function, this guy will take t of n time, and as we are doing minus 1 here, this line will take t of n minus 1 time. So let's take this example in notepad. We'll understand better over there. So I copy pasted that function here. So if you see, this t of n is nothing but this 1 plus this t of n minus 1 plus these three ones over here. So 1 plus 1, 1, 2, 3, 4. Let's write it properly. T of n is nothing but t of n minus 1 plus 1. Why I am taking plus 1? Because all these are nothing but constant only. So for simplicity, we can write plus 1 directly. And this will be true if and only if n is greater than 0. You can see here we are having condition n is greater than 0. What if n becomes 0? If n becomes 0, we are returning 0 only. So if n becomes 0, n equal to, and this is what we called recurrence relation. And to solve this recurrence relation, we have two methods. One is master theorem and one is substitution method. Master theorem is not applicable for all kind of recurrence relations. It has some limitations. So that's why we will go with substitution method. What we do is substitution method. Let's take our relation. So what we do in substitution method, here to get t of n, we need to find out what is t of n minus 1. How we will get that? We will substitute, I will show you, t of n minus 1, t of n minus 1 minus 1 plus 1 plus 1. So what is happening here? I have substituted value of n. If you see, I replace this n with t of n minus 1 plus 1. So this entire block is nothing but t of n. So I substituted this value for this n. And that's why I got t of n minus 1 and this 1 over here. If I refactor this, we can write this guy like this also. Now I want to figure out value of t of n minus 2. How we can do that? Substitution method. For n minus 2, I'll do same. T of n minus 1 plus 1. You might be feeling this is little complicated, but I did nothing. I just substituted value of n, that is this value, at the place of n only. So here we were having n minus 1, I write n minus 1. Outside the bracket we were having plus 1, I wrote plus 1. Other things are that only. I can rewrite this guy like this also. So now how far should we go? Value of n is infinite only, so we can't write infinite statements. So generally we write till third iteration, and if you see, we are having one pattern. As this n is increasing, or we can say decreasing, minus 1, minus 2, value of constant is also getting decreased in same proportion. So we can rewrite this guy like this. I'll replace k with this guy, and this n minus k will eventually become 0. So first find out what is value of k. If this becomes 0, n is nothing but k only. So in this equation, if I put value of k nothing but n only, this n minus n will become 0, and what was the value of 0? It's a constant. Here we have written, if n is 0, we consider 0 only, but it is nothing but constant. If I write like this, then my time complexity will be big O of 0 plus n. 0 is nothing but constant. Here you could get 1 also. Why? Because sometime if you see, we might have written here, you can see here I written 0, here I written 1. So you can have condition for 2, that is if it's equal to 2, n is equal to 2, you are returning 1. At some places you might be returning 1, you might be returning 2. So based on that, value of this constant will get changed. But as it is constant only, there is no meaning of considering for time complexity. And time complexity for this guy will be big O of n. And this is all. This is, you can say, all recursion basics. So you got to know what is types of recursion. You saw their examples also. You got to know how to get recurrence relation and how to solve it using substitute method. And if you want to see some more examples on recurrence relation and how to solve it, please ping into comment section. In next video, I'll take some more examples as well.